Hi friends, welcome to my channel. Let's have a look at problem 2640. Find the score of all prefixes of an array. In this video, we're going to explain a solution based on the use of partial sum. Basically, we see partial sum. It can be referred to as a prefix sum or suffix sum. So any variance. So basically this problem we need to use a slightly variance. Let's look at the problem statement. So here we define the conversion array, convert of an array is given as a name array as follows. So basically the ith element of the conversion array will be the sum of the current element as array plus the maximum of the elements in the original array to the left of the current number and inclusive. So this is how we define the array, right? So we define the score of an array as the sum of the values of their conversion array, right? So here, given a zero index integer array called nums of length n, we want to find an array called answer of length n, where answer I is the score of the prefix nums for this, right? So if we just want to compute one score for the whole array, right? We just need to find the conversion array and then do the sum, right? So, but if we want to find all of them for all the prefixes, just we can regard each of the sub arrays starting from index 0 and ending at index I as a array and then compute its conversion score. But then if we add one more element, then we can use the previous result, right? Then so this way, so essentially we can use the partial sums, right, or prefix sums. So this is what we can do. So also we will code in this coding session. So here are two examples. So for the first example, we can first get the conversion array. So for the conversion array, let me write here maybe. So here we have an example. Let me copy this part here, right? Then let's do the convert. So let's see what they use to convert, right? So at index 0, right, the current number is 2, and the maximum up to now is 2 itself. So we get 2 plus 2 is 4. And at index 1, so we're going to have 3. So 3 is also the current maximum one, right? So we're going to have 3 plus 3, that is 6. And this one, the largest one, will be 7. And this number itself is also 7. So we're going to have 14, right? And at this 5, we know the largest one up to now is 7. So 5 plus 7 will be 12. And this 10, because this is the maximum one, so we're just double it. So we get 20. So this will be the conversion array. And then if we want to compute the score for this single element 2, so we have this 2, right? If we want to compute for 6, so we're going to have 6 plus 4 plus 6, that is 10. And let me write down maybe. The answer will be at 4, if we have 4 and 6, we have 6 plus 4, that is 10, right? And 14, so we're going to have 10 plus 14, that is 24. And then 24 plus 12, that is 36. And 36 plus 20, that will be 56. So this is the output for example 1. So similarly, you can do example 2. But example 2 is very special because this list, its elements are in a non-decreasing order. So in other words, increasing, but not strictly increasing, because we can have equality, right? But now this one, so we can easily get its conversion array. It's nothing but the double of this original list. It's just 2, 4, 8, 16, 32. right? And then if you consider the answer, so we can get 2, and then we compute prefix sum or partial sum, we get 4, and then we get 8. So 8 plus 8 will be 16, and 16 plus 16 will be 32, and 32 plus 32, that will be 64, right? So this is the output for the second example. So with that done, let's also look at the constraints. First, the list nums is not empty because its length is bounded below by 1, and its length is bounded above by 10 to the power 5. So this one is a decent large number. In other words, so here our algorithm, so if based on the analysis, will be O of n, right? And then for the elements in the list is bounded below by 1. In other words, it's positive integers, and bounded above by 10 to the power none. This is basically on the range. So with that said, we are ready to do the coding. So for the coding, actually first we can get the length of this nums list. So notice that n is greater or equal than 1 by assumption. And then first we want to, based on this definition, we need to compute we want to maintain the maximum so far, right? And also we want to compute the prefix sum. So we want to do this in one go, right? So what we're going to do is that let's first define a variable called max so far. It will be num0. And also we want to have sum so far, right? The sum will not be the prefix sum itself. It will be something like this, right? But also I want to compute the prefix sum after we get the conversion, because for the first element the conversion is itself, and then the corresponding prefix score will be twice of this guy. So we're going to get num0 times 2. So this will be the first element, right, in the return. So now let me make a list, and then let's first add this sum so far to this result variable. So we can regard this several lines as a preparation, and then we're going to do iteration, right? Iterate. So for this, let's do for I in so let's see, for I in range 1 to n, right? Because we have already considered the index 0. So some people may prefer to do I and y enumerate this guy, but we need to exclude the first element because of this way of writing the code, right? So here we just subtract the indices. Then we will, let's see, maximum so far. So this can be easily updated. Will be the max, right? Max the previous state and the current number, that is nums I, right? And then we want to compute the sum so far. The sum so far will be at another conversion score. So the conversion score will correspond to the max so far plus the current element. So that will be max so far plus nums I, right? And then after we set this sum so far for the subarray up to index I, then we can append the result to the result variable. So append this sum so far. Then we are ready to do the return. So we want to return the result state, final state. So this is a solution format for this problem. So before we make any comments, let's first do a check. We passed the first example. So now let's look at the generic case. Yeah, it passes all the generic cases. So here, actually, let me do some performance analysis. First, the time complexity is very easy to analyze. So we just do a linear traversal of this nums list. Therefore, the space complexity will be O of n, where n is the length of its nums. So as for space-time complexity, so actually here, for the return, we need to use On of space, because each corresponding to each index. So this will be O of n, take into consideration including return. Otherwise, other parts, so it will be O of 1, right? So we just maintain two running variables. One is max so far, and one is sum so far, right? And then in between we did a standard for loop. So basically, this problem is let's see, it's a sort of straightforward one, though LeetCode marked it as a medium problem. Here, it provides a good example for using partial sum. So, but here it's just with some slight variance, right? Not if we do not have consider this part, so basically it will be a prefix sum. Then we just verify it with this max so far added, right? So if you ignore this part, so it do sum so far and increment by the current number, it will be the standard prefix sum or partial sum. And in this one, it's just a slight variant. So with that said, I guess that's a solution format. So you can devise other formats. That's about it for this video. Thank you.